Hi friends, welcome to follow up. Let's have a look at problem 2814. Minimum time takes to reach destination without drowning. In this video, we're going to explain a solution based on breadth-first search. So here we're going to write in a verbose fashion. So the main purpose is to digest the idea and give one solution. So actually there are a lot of possible optimizations. So here the problem is marked as hard. Actually, if we digest the logic, so it's rather straightforward to write a solution. So here we are given an n by m zero indexed grid of string called land. So currently we are standing at a position S, and we want to get to the cell containing the destination. Let's call it the letter D. So there are three other types of cells. So the dot means empty, X means stone, and star means flooded. So at each second, we may move to a cell that shares a set with our current cell. And also at each second, every empty cell that shares a set with a flooded cell becomes flooded as well. So there are two problems ahead of our journey. So first, we cannot step on stones, so we can understand that the stone cells are obstacles. And also we cannot step on flooded cells, since we will drown. So we want to return the minimum time it takes for us to reach the destination. Otherwise, if it's impossible, we're going to return -1. So note that the destination will never be flooded, right? So here we have three examples. So basically you can look at the first two examples to digest the output. So the first example, it takes 3 seconds. And in example 1, it's impossible, right? So here the constraints are the following. First, n and m are both bounded above by 100. So in other words, we have at most 10,000 cells. So the land consists of only S, D, dot, star, and X. So there is exactly one cell with letter S and exactly one cell with letter D, right? So with that said, basically we can look at the idea first. So here our strategy will be based on breadth-first search. So because we want to find the minimum time, so each second we can move one step, so we can also think of this as shortest path. So as we mentioned, shortest path, and actually we can also think of this algorithm, Dijkstra's algorithm. But here we just use the vanilla breadth-first search. That will be sufficient. And also in this problem, we can do breadth-first search from the flooded cells and from the S cell simultaneously. So this will be more efficient, right? So we can regard these two items as two optimizations we can think of. But here for this problem, what we want to do is that we first do one breadth-first BFS to get the time for each empty cell to be flooded. And then we do another BFS, so to find a minimal time, right? So in this case, we want to make sure. So for when we visit each empty cell, we want to make sure that cell is not flooded yet. So here, caution or constraint is that we need to make sure the cells we are visiting at time t is not flooded yet. So this is also the purpose of the breadth first search. So with that said, let's look at coding. So basically, that's the core part. So now we do it in a order. Let's say we first do a breadth first search to get all the information, and then we do the second breadth first search. So actually, as we mentioned, we can do the two breadth first search simultaneously at the same time. But here, in order to make the exposition or explanation more clear, so we want to do it separately. So first, I'm going to get m and n. So this will be the length of the land and length of an array in the land. That is, m will be the number of rows and n will be the number of columns. So this is our convention used here. Slightly different from here, because here n is the number of rows and m is the number of columns. But this is just a symbol, nothing essential, right? So then we can have a start. We want to find a start. We want to find a destination. We want to know the obstacles, and also we want to know water cells, and also empties. So this will be, let's set to be null. So here I'm going to use set, right? Set. So it's easy for membership check. And then I'm going to write with some redundancy, that is still with the purpose of explaining the overall logic clearly. Then actually we can, after we solve this problem, we can design code to make it more compact, or to make it more fast, right? So here let's do an iteration for I in range m, for j in range n, right? So what we want to do is to check the land, right? If land ij, so equals s, right? So this is the start. So I'm going to set start to be ij, right? And then I'm going to basically copy this part. Let's make it a else if this one is a D as a destination, so we are going to set this to be destination, right? Dest to be ij. Then let's copy it again, right? So if this one is dot, in other words, it's empty, right? So we're going to do empties add, right? So this is the set method. And then let's copy again. So if this guy is x, so that will be obstacles, right? So actually we do not use it specifically, but let's do it here, because we have only 5 kinds of cells, right? So water and so ij, in this case there will be waters, corresponding to the cell with a value star, right? So now this for loop actually determines start, destination, and the water cells and the empty cells that to be flooded or to be traversed. So with that said, let's do our first breadth first search. So here, because the empty, the start position can be flooded. Let's see empties. I'm going to add this start to this set, and then let's initialize a queue. So here I'm going to use collections stack. So because we're going to use pop from the head and also append from the tail, so we want to use pop left method. So here we want to do ij0, right? So for ij in water. So these are at time 0. So it means that at time 0, this cell ij is flooded. And to aid the traversal or breadth first search, so we want to use collections default dict, right? So what we want to do is that we want to get all the time for a cell that is first flooded. So here let's get IGT equals Q pop left, right? That's why we use deck. And then we want to check if IG are not in visited, right? So in this case, we're going to add this tuple as a key, right? So and T is the time this cell get flooded. And then what we want to do is to check the neighbors. So for RC in, so let's use that. So I minus 1 J, I plus 1 G, I G minus 1, I G plus 1, right? So we want to check if RC, so only those cells in empties can be got flooded. So if it's in empties and it's not visited yet, not in visited. So what we want to do is to append this to the queue, right? We include this one, but the time will be T plus 1, right? So after this for while loop, then we get a new state of the visited set. Basically, it's a dictionary. So the key will be the cell positions, and the time will be T will be the time and the cell got flooded first time. So now we are ready to do the second breadth first search. So first let's check this. If start in water, right? So we want to return -1, right? Then let's do it again. So collections deck, right? So we want to pass the start position, right? So let's unpack this start. So and then start the time is be 0, right? And then let's use a thin set to aid the traversal to avoid repetition. Then the same thing, same as above, but we need to pay attention to the checks, right? So first, let's get I, G, and T equals Q pop left, right? So if IG so equals destination, so we just need to return T, right? And then if IG not in thin, so we're going to check its neighbors, right? So first we need to add this position to the dictionary, right? And then what we want to do is to let's copy this one. For these 4 positions, let's check. So if RC, right? So we need to consider this one is in empties, and RC not in thin. And also we want that because if we want to visit this position at time T plus 1, we want to make sure this cell is not flooded. So the not flooded condition is that RC not in visited, right? So because that means that this position can never got flooded, or so T plus 1 is less than visited RC, right? So if this is the case, so we can append this RC T plus 1. So this is 1, right? Another case is that RC equals destination, right? And RC haven't got flooded when we visited that. This is the condition. So for this, we just need to return T plus 1, right? Then if after this while loop, nothing has returned, so we're going to return -1. It means that no valid path. So with that said, we finished coding for this problem. Now before we make any comments, let's first do a test. Collections. Yeah, it passes one example. Now let's look at the generic case. obstacles is not defined. Let's see. Obstacles. So now let's test again. Yeah, it passes all the test cases. So here actually we wasted some time by doing the two breadth first search in order, right? And this is actually something we commented at the very beginning. So in order to improve the code, the first thing we want to think of is that we can do the two breadth first search at the same time. So this is a good exercise. This is the one. Another thing is that we can think of dexterous algorithm. So this is another way of improving the code. So here, actually, the obstacle is not specifically used, so you can actually ignore that, or just use some dummy variable. So basically, this problem, though marked as hard by leetcode, so it's the method in solving it is standard, both the vanilla breadth first search or the dexterous algorithm. So both are very classic, right? So with that said, basically that's about it for this video. Thank you.